Okay, as we can see on the screen, we have used our own MySprite class, and we initial the value for the game, and then we start a game loop. In this game loop, we have an event listener, and we will use some collision detection techniques to detect maybe whether the flaming arrow hit the player or hit the dragon. So today we will continue with this.
Okay.
So in previous lesson, actually we have used the animation of the arrow. Last time we have tried maybe to see whether the arrow can move on the screen, but it's incomplete because we decrease the x coordinates of the arrow, and we try to maybe make the arrow moving from right to left on the screen. And then we run the game, but we cannot see the flaming arrow moving, right? Maybe you can try to run your program. Yeah, we cannot see the arrow moving because we missed one step. It's a very important step. We need to update the ticks of the sprites. So turn off the window, turn off the game window. Let's go back to the editor. So move your scroll down and move your mouse maybe to the, let me see which line. Screen dot bleed. Yeah, we need to insert some code after screen dot bleed BG. So it should be on line 143. We need to update the sprites here. Yeah, press return twice to leave empty line above and one empty line below. So let's start coding from 144, okay? So let's start with the command first. Command update sprites here.
Okay.
Okay, good. Then press return. Let's write if not game over, colon. We need to check whether the game is still live. If not game underscore over.
Oh God, why is it so laggy? Okay.
Okay, then press return group dot update. Because we use group to manage all the sprites, so we can use group to update all the sprites, ticks, and the rate, the animation rate together. So group dot update parentheses, and we will pass two arguments into the update method. The first one is ticks, T-I-C-K-S, ticks. We define ticks, at the beginning of the while loop. The ticks actually it means maybe the time spanning from the pygame.elite until now, okay? And then the next is the rate. The rate here we set it to 50 milliseconds. Okay, great. Now save the Python file and run the game again. Let's see whether the flaming arrow coming. Anything on the screen? No. Pygame.display.update. Okay, let's go back to you change to PyCharm. There's no error, no alert. arrow.x. Let me check for you. Reset. So in 9,138. Arrow.x minus. If arrow.x is. So we still cannot see the flaming arrow. Arrow.update. Okay, maybe we can write console. We can print something to show maybe the ticks. So in 9,143, let's write a print here, a print prompt. Print ticks.
Yeah.
Then save it and run again.
There's an error. Wait, there's no error. What?
Go back to the editor and see any prompt here. Okay, we cannot see the print. Okay. So the program maybe didn't run to here. If not, game over. Screw up. At the beginning of the while loop, let's write a print. Go to the game loop.
Oh God, why is it so laggy? What the heck?
Not sure. It's okay. Here my sound and maybe my video is okay.
Yeah.
Okay, that's good. Go to the while loop. Scroll down.
While loop? Oh.
Yeah, the game loop.
Oh, it's here.
Okay, at the beginning of the while loop in 124, print ticks here.
Print ticks? Okay.
Yeah. Oh, I know what's the error. From 9,136, you didn't use indent, so all this program becomes the main program.
Bruh.
Yeah, all this should belong to the while loop. Should be in the game loop. Yeah. Then I think you can remove the print in 9,124. Remove the print. 9,124. That's print. I think no need. And save the file and run again.
Yo.
See? But
wait, what is this thing on here? Is this water?
Just a background. You can change maybe to your pictures. Never mind. Now you can see after we load the player, load the dragon, they have the animation effect, right? Because we use our own MySprite class. But at the beginning of the game, we see the flaming arrow, but it moved from the right to left just once, right?
Yeah.
If we want the flaming arrow to come back again, so what do we need to do? We want the flaming arrow to come from right to left again, like a loop.
We have to repeat it?
Actually, we have a while loop. The game loop is a repeat.
I mean, we have to make the thing randomized.
Randomized. Because the flaming arrow move from the left to the right. Underneath the screen, maybe we cannot see the movement, but the flaming arrow is keeping moving to the left now, it's still moving to the left. So we need to use maybe if statement to check if the flaming arrow touches the left edge of the screen, then we need to make it to reset the flaming arrow to make it start from the right edge again.
Right edge, so it's
Yeah,
Oh,
after
shit.
after it touches the left edge, we reset the flaming arrow's x coordinates to the right side.
Oh, so you don't like fire a bunch of them. So you just keep repeating the single one.
Yeah, because you know the flaming arrow is still moving to the left now. If we don't do this, it's keep because we are deducting the x coordinates of flaming arrow. So it's in each frame, because the frames they are in a loop. In the loop, we keeping up minus the x coordinates of flaming arrow. So it's still moving to the left, maybe far away to the left. But we don't need it to move so far away to the left. After it maybe touches the left side, just grab it back to the right side and start to move again. Okay, now turn off your game window and then let's go back to the editor. So we need to check. We need to check in line 138. Okay, line 138. Press return. 138, not 148. 138.
Here.
Okay, we need use if statement to check if arrow.x less than dot capital X less than -40 colon less than sign.
Oh, I'm dumb.
Colon, then space. Or you can press return also can. If only one line of the code, we can write on the same line as the if statement, or we can use return. Then write reset underscore arrow parentheses. Parentheses. This is a method we defined in previous lesson. Okay, tell me what we did in this reset arrow. Okay, you go back to check what we do in reset arrow function. Actually, it's in the same file. You just scroll up to find reset arrow method.
Here.
Yeah.
Oh, so just transport it back to okay. I see.
What did we do here? What we did here? We use
X800.
We reset
so it's
the arrow's position, right?
Yeah.
The x coordinate is 800. Actually, it's the right edge of the window. And y is a random value. Maybe it's between 250 to 350, right?
Yeah.
Reset the position of the arrow. Okay. Let's return to the editor. Let's return to the arrow moving code. Scroll down. 140. Yeah, in line 140, we reset arrow and we check if arrow.x less than -40, which means the flaming arrow is moving out of the window from the left side. Then the x coordinate will be less than -40. Then we reset arrow. We move back to move the arrow back to the right side. Okay, now let's save this file and then we rerun the game to see maybe the flaming arrow will come on the screen from right to left.
Wait, what did you say?
You just rerun the game, save the file
Oh.
and rerun the game. And let's see maybe whether the flaming arrow were coming from right to left and repeating to this. See, now it can come, yeah. Up it maybe moves out of the screen, then it come back from right again.
Yeah.
Okay, good. Now the animation, we have the 3 animations. Now, next, we need to use collision detection techniques, maybe to check whether the flaming arrow hit the player or whether the flaming arrow hit the dragon or whether the dragon eat the player. So at least 3 times, we need to use the collision detection 3 times to check these. Okay, turn off the window and then let's go back to the editor. So firstly, let's check, did arrow hit player? So let's start from line 142.
100.
And yeah, and leave 1 empty line below.
Okay.
Let's start with the comment. Did the arrow hit player? Question mark. This command. Did the arrow hit player? Question mark. Press return. So we will use the if statement to check if pygame.sprite.collide underscore rect. We will use collide rect to check. And then we will put 2 parentheses. And then we will put the 2 sprites inside, arrow, comma, player. Because here we will check whether the arrow hit the player. So we put arrow and a player inside. And if the arrow overlap with player, this if statement will be true, and which means the arrow hit the player. So first we reset arrow again, reset underscore arrow, because the arrow hit the player, but the game still live, because if the arrow hit player, we just move the player maybe a little bit to the left, but the game keep live. Okay, so we reset arrow.
Okay.
We call this reset arrow method. Press return. And then we move the player 10 pixels to the left. Okay, do it. How to move the player 10 pixels to the left?
Move.
Not move. Just now we move the flaming arrow on. How to move the flaming arrow on the screen? Check. Just 2 lines. No, just 2 lines above.
What?
In line 137. How did we move the arrow to the left? Show this effect of the arrow moving. We just
arrow.x.
Yeah, we just deduct a value from arrow.x. So now if we want to move the player maybe 10 steps to the left, what should we do? We just maybe deduct 10 from player's x coordinate.
Okay.
So you should write player.x.
Oh yeah, wait, I'm dumb.
Minus equals 10 pixels. Just write 10 here, which means, which is no need pixel, just minus 10 is okay. This means 10 pixels. minus equals, then we need to write 10. We cannot use negative 10, just 10.
So
Yeah. Actually, this equation no need colon. This is a self-deduct. This equation is equivalent to player.x equals player.x minus 10.
yeah.
So in each frame, we will minus 10 pixels from the x coordinates of player. So which means in each frame, if the flaming arrow touch the player will move a little bit, will move 10 pixels to the left, which means it will reverse 10 pixels. Okay, let's
Okay.
save the file. Then you can run the program and see the effect. See, when just now the player moved back 10 pixels.
Yeah.
When the arrow touched the player. See, it push the player back 10 pixels. Okay.
So we have to do the dragon as well.
Yeah, as well. Yeah, likewise, maybe actually it's the same now. You can do this with the dragon. Okay, do it by yourself.
Yeah.
Okay, let's do it now.
Wait. Okay.
Actually, like the code's very similar. You just
I know.
start with the command. Did the arrow hit the dragon? Just start with the command. Did the arrow hit dragon? Yeah.
What? Okay.
Yeah, good. So we use collision detection twice to detect whether the arrow hit player and whether the arrow hit dragon. And next, we need to use detection again to check maybe whether the dragon eat the player. Okay, do it.
Sure. We want me to collect. Okay.
Try to leave an empty line between different functions, different blocks. Okay. Now this one you should start with a comment. Did dragon eat the player? Question mark. Leave an empty line below.
Wait. No.
Yeah, and if the dragon eat the player, which means the game is over. So we don't need to reset arrow because if game over, we don't need the flaming arrow to moving again. We just do one thing. Set game over to true. game underscore over, because we have a variable called game over. Remove set, please. Just game underscore over equals capital true. Press return to leave an empty line below. Then you try again. Save the file and rerun the game. Which means if the dragon touch the player, then the game is over.
Yeah.
Yeah, everything stopped. Okay. Turn off this window and let's add more functionalities. So we have the checking for dragon eat player, but we also need to check maybe whether the dragon gets defeated. If the dragon get defeated, which means the dragon was pushed to the left side by the flaming arrow. So let's continue with the code in line 155. Press return to leave empty lines above and below. And let's start with the comment as well. Did the dragon get defeated? Press return twice, leave an empty line. And we use here we don't need collision detection now. We just to check the dragon.x property. So if dragon.X X less than -100, the empty line is below this line, not above. The comment is the dragon get defeated together with its block. Okay, if dragon.x less than -100, which means the dragon has been pushed to the left side. So we set two values. U underscore win equals capital true. Press return. And game over equals true. If the player win, game is over. If the dragon win, game is over as well. Okay, press return. Okay, by this, if the dragon touches the left side of the window, then player win. But because we don't have the jump functionality now, so it's very hard to make the dragon touch the left side. So we will test this maybe after we have the jumping functionality. Okay. So let's continue with the jumping function. So press return twice to leave some empty lines. Yeah. From here we will write the code for jumping. So let's start with a comment. If the player jumping ?
Oh, wait.
Write comment first and remove indent to remove indent. This is comment. Is a player jumping ? Press return twice. Okay, and then let's write the code. We check if player underscore jumping :
What did you say?
If player underscore jumping, we have a variable called player underscore jumping. The empty line should be below this line, not above. If player underscore jumping, then player dot capital Y plus equals jump underscore VEL. If the player is in jumping mode, we apply the jump velocity to player.y property. Leave spaces before and after the plus equal sign. Plus equal, be careful, here is a plus equal. No space between plus and equal. This is equivalent to player.y equals player.y plus jump VEL.
Oh, wait, plus jump or equals?
I mean, this line plus equal, no space between plus equal. Yeah, this is a complete equation.
Okay.
This equation is equivalent to player.y equals player.y plus jump VEL. Okay, understand?
Yeah.
Okay, which means we add jump VEL to player.y each time. And then we set player.y, and we also need to reset jump VEL as we learned before. So press return to next line, jump VEL plus equals 0.5. Plus equals 0.5. So as we learned before, the jump VEL is -8 at first, which means we minus the y coordinates, the y property of player. So the player will be a little bit up if compared to last frame. So in each frame, the player will move up, 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 but the gap will be smaller, smaller because we increase 0.5 to jump velocity in each frame. So there is a point, maybe the jump velocity becomes 0, then which means the player.y cannot be less anymore. So the player touches the highest point. And then the jump velocity become a positive value from that. So the player.y will be maybe player.y will be greater and greater. So the player will start to drop. And we need to check when player.y touches the start y value. So which means the player touches the ground, then the jump mode is in, maybe we need to disable it.
Can you double jump?
We need to check now if player.y is greater than player underscore start underscore y.
Yeah, so.
Let's start to check. We use the if statement to check now. If player dot capital Y greater than player underscore start underscore Y. This value records the start Y value for the player. Press return. If the player touches the ground, then player jumping equals false.
What? Player?
Player underscore jumping. We set player jumping to the mode, to force, equals capital force. Press return. Player dot capital Y equals player underscore start underscore Y. We reset player's Y position to the start value. Player underscore start underscore Y. Press return. Jump underscore VEL equals
Wait, no. Jump underscore what?
VEL equals 0.0. Press return, save the file.
Okay, saved.
Okay, then you can run the program now because we have all the functionalities. Okay, I turn off my Zoom and you join again. You can try to use a jump mode to test it, okay?
Okay.